Alright, so today we're going to be working on an 820-2530 here that's dead. I know, this is an antique. Why I'm bothering is beyond me, but every now and then, what the hell. So I'm going to be trying something a little different today. I'm going to be streaming just the Twitch and then editing this short version of YouTube. I used to think that I was kind of screwing over the YouTube people by only streaming to Twitch, but I'm getting a lot of comments on the shorter videos I'm doing saying I want to see more of these screw the streams. So I'm thinking I'm going to do something like this for the next few weeks. I'm going to upload the full stream to VidMe. I'm going to stream to Twitch, and then I'm going to upload the edited version of it to YouTube, and maybe that will be the best compromise between all three different ways of viewing this type of content. So today we're going to get started. This is an 820-2530. Now we do get a green light on the charger here. As you see, we have a light on the charger, and it is turning green. However, the person says that it won't charge the battery. So the first thing that I would want to do if it says that I cannot charge the battery is I want to look up what would charge the battery on this machine. So if I look at the schematic over here, that down here, P-bus supply, battery, charger. And this is going to take the voltage from the charger, that 18 volts from the charger, and it's going to turn it at the end into 12.6 volts from my system. PP-bus G3 hot is simply another way of saying 12 volts here. So if I were to go to the power aliases page down here, you'll see that PP-bus G3 hot on this page, it says PP-bus G3 hot is 12.6 volts. So what I'm going to want to do is see if that's creating 12.6 volts like it's supposed to. So this is a buck converter. If you don't know what that is, you could watch any of my videos on what a buck converter is, and they will go over that in detail. Let's take a look. So the area where that chipset is actually looks pretty damn nice to me. I don't see anything wrong over here, except for the fact that my microscope, as always, is out of focus. And I can't blame Jason for it, because Jason is on vacation in China. So as much as I'd like to blame him for it, it is not his fault. So I'm going to just turn on the multimeter here. We're in voltage mode, and we're going to see what we're getting at that fuse. So if I were to go over to that fuse, which is going to be F7000 over here, I should get 12.6 volts. And what I get on the meter is 0.183 volts. So, well, there's a few things that this chip is going to need in order to work. Firstly, it's going to need PP3V42. And we know it's getting PP3V42 because we have a light in the charger, which we wouldn't have otherwise. Over here at pins 19 and 20, charger VDD should be 5 volts. So if we were to measure charger VDD over here, you'll see that we get 5 volts. So that's not it. At charger DCN, we should be getting the 16 or 18 volts from the charger over here. So let's just check on where charger DCN would be. We're going to look over here for that. And let's see what we get there. 16.5 volts. Okay, so let's see where our problem is. So these two transistors are supposed to take the spikes of 16 volts from the charger, which is coming in through here, and send spikes through the coil. So a spike of 16, spike of 0, spike of 16, spike of 0, and that's supposed to average out to 12.6 volts. So let's see if any voltage is actually making its way through to here. These two transistors are here as the reverse current protection to ensure that the battery doesn't try to charge the charger or anything funny like that. So let's take a look at Q700 and Q7001 up here. So let's see if voltage is making its way from up here. So 18V G3 hot charger. Any G3 hot voltage is a voltage that should be there at all times. So let's find Q7000 up here. So we're going to go over to Q7000, and on Q7000 up here, let's see what we get. So we have 18 volts is supposed to come in through there. So it does look like we're getting 16 volts on the input of Q7000. So we are getting that. Now, this over here is what we call a P-channel MOSFET. This will only open if the voltage in the gate is lower than the voltage in the source. So on the source, which is pins 1, 2, 3, as can be seen over here, we are getting 16 volts. Now, the gate, which is going to be pin 4 over here, this is supposed to be getting less. And as we can see here, it's getting the exact same 16, which means that it's not going to open, which means that no power is going to flow through here. So let's try to figure out how it is that the voltage in the gate would be lower than the voltage in the source. So we have R7098. which is going to take the voltage from the source and place it on the gate. R7098 ensures that this transistor will never open. However, if we were to add another resistor between the gate and ground, we'd have what's called a voltage divider. And if we have a voltage divider, then we can lower the voltage in the gate. But what if instead of tying the second resistor to ground, we tie it to a chip that can control whether it goes to ground? Then we'd have a voltage divider that we could turn on and off at will, which is what you see here. So R7098 sits between the 18-volt rail and the gate, and R7001 over here sits between the gate and U7000. Now, U7000 over here at charger A gate can send R7001 up here to ground at will. So it's U7000's choice whether to do that. Now, there are a couple of things that can go wrong in the circuit. These resistors can corrode. The paths between them can corrode. This capacitor over here could short, making this a wire. So the first resistor in the voltage divider of C7063 shorts would be a wire, which means that this would never act as a voltage divider, or Q7000 could be shorted internally. So the first thing that I would do to rule out several things, the transistor being bad and this cap being bad in one immediate measurement, is measure the resistance between pins 1 and pins 4 of Q7000 up here. So let's do that. So we're going to unplug the charger for this. We're going to check between pins 1 and 4, and we should get about 100 kiloohms of resistance. And as can be seen, we get 100 kiloohms of resistance, which means this cap has not gone bad, nor has the transistor internally shorted. Now and R7098, I'm going to guess, is good because we have 100 kiloohms of resistance between here and here. Now we're going to check if R7098 has a good path to R7001. So on this side of the board, we're going to see R7098 over here, and I'm going to make sure that that's got a good path to R7001 up there. This, we're going to measure between U up here and U down here. And that trace is fine. Less than 2 ohms of resistance. That's just the multimeter being a cheap multimeter. This means that most likely my issue is going to be with one of two things. Either A, the SMC, notice here the SMC has a data line with the U7000. The SMC is telling my U7000, keep that transistor off. Or B, U7000 is fucked. I'm going to hope and pray that it's U7000 that is to blame here, because if it's something else, on a board that's from 2009, then this is just going in the garbage where it belongs. And we are going to repeal and replace this with a new chip. Now, do keep in mind, this board is so old, it actually uses the ISL 6258, not the ISL 6259, which I have, it appears, 3 left in my spool. So I have 3 2008-9 boards left that I can fix before I'm done. I am so cheap that the only reason I'm even bothering with this is because I need to get rid of my old chipsets. How are these boards worth it to fix? They're not worth it to fix. And with the newer machines, it may be worth it, because with newer machines, the data is a part of the motherboard. On these, I have no idea why anybody bothers. You can just take your drive out, pop it into something else. I actually forgot to check current sensing, but those resistors look like they're probably fine to me. Either way, if we wasted our time, we will find out shortly. Yeah. I'm sorry to hear that Firefox sucks so much for you. Alright, so we're going to add some lead solder. We're going to mix it with that lead-free solder, make it a little easier to wick up and remove. And we're going to wick. Okay, we're just going to solder on our pads here. Almost forgot the flux. Can't have fun soldering without new flux, now can we? This is not the ideal tip for this. Okay, and get ready for the new chip on there. By new, I mean this chip that I bought back in 2012, maybe? Yeah, this spool is from 2012, and I've still got it. Look at that nice ISL 6258. Okay, flew into place. Make it dance a little. Now we're going to push it down, make it nice and flat on the board. And any excess solder is going to get removed with my micro pencil. You need a web browser. Why not do it yourself, says he. Hot, bro. My focus on perfection is killing me. Why am I focusing on perfection when I tell all of you not to focus on perfection? God damn it. What are you using these days to view blueprints? I use Paul Daniels' open board view, proudly. Okay, now we're going to plug this thing in and see what we get on the charger. Okay. So I went from having, here we go, green light. I was just about to say that my green light went away. Wouldn't be surprised with knowing where I bought. I bought that chip before I knew that L2 were scammers. That chip is so old that that was purchased when I thought L2 were like a real company. Oh man. And hey, voltage says, let's okay, voltage over here says 12.3. You all know what that means, right? That means that this is not going to see a battery. All right. So let's check diode mode to ground on the SMC data lines. So, over here, you'll see that the SMC is going to talk... whoops. The SMC is going to talk to the battery and the battery indicator light on the side, which then talks to the battery charger. If this data line is not working, or these resistors are gone, or this chip is not working, or something is shorting it to ground, then what's going to happen is that this is not going to be able to talk to this. And what happens is that this chip over here will create 12.3 volts. It only creates 12.56 volts once the SMC has told it to, but before the SMC tells it to, it creates 12.3. So just to confirm that I'm probably screwed and need a new SMC for a 2009 machine, in which case I'm not going to bother fixing it, because hell if I'm chasing that down. I have a better chance of getting a date with Ruby Lewis than I do buying a working SMC to a 2009 MacBook Pro. I'm going to plug it in and see if it now sees this battery, just out of curiosity here. So we are plugged in, and let's see if it gives me an orange light. And it only gives me a green one. If I were to, let's see if I plug in the battery indicator over here. Do you see anything? Nope. It sees nothing. Now, it could always be that that battery is bad, but Do you think that's going to be the problem with our luck? I don't think so. Hi. All right, let's check and see if there's a short to ground on pin 10 or 11. You never know. It could be a bad ISL. Or it could be a bad SMC. Like it always is. Like it always is. All right, so diode mode to ground on those pins. I'm not finding an SMC for this. Balls to that. Balls to that, man. All right, so we're going to check diode mode to ground on pin, and we're supposed to be getting something like 0.441. Here. What the? I got to make good contact. 0.448. Acceptable. 0.436. Acceptable. Bad SMC. So this is not shorting it to ground. Most likely SMC issue. Let me just try with another battery just to confirm that I am not making any assumptions I shouldn't about the health of that battery. All right, so with a different battery we get green light, not orange, and battery indicator doesn't recognize it. Lame. Some bullshit. All right, so let's check the pull-up resistors just to make sure that they are... Actually, we can check the pull-up resistors by checking voltage at those pins. So let's check voltage at either of those pins, because that'll actually be faster than finding the damn pull-up resistors. All right. If we get 3 volts, then we know that at least the pull-up resistors are pulling the data line signal up. .4, 3.4. And of course, if that's with the battery indicator unplugged, so that can't be pulling down my signal. And we check the voltage on PP bus G3 hot, and it's 12.3, because the SMC ain't doing its job. And the SMC has to be on, so I know that SMC reset circuit is working. I know that because in my because my charger light is turning on, which it wouldn't if the SMC was dead. So let's give the board a once-over, and then perhaps, just because, make the SMC dance a little bit, because you never know. It could just be corrosion under the SMC, and that may be it. So let's take a look over the board. And, hey, little fella. Hey, do you know, did you break my SMC? Did you break my SMC, little guy? I think maybe you broke my SMC. Oh, you broke my SMC, didn't you, you little bastard? Didn't you, you little bastard? Oh, you're so cute. Look at its little eyes. So we've got this little bug over here. And what, did you fuck up my SMC? You probably did. All right, so the SMC on this board is located up here. And we are going to give this a nice reflow. This has no edge bonding on the SMC, as someone pointed out. Will you be willing to fix Teslas? I don't know. I can't even drive, man. It's wrong idea. So we're going to preheat the board for a little bit. No edge bonding means been fucked with already. No, not on this one. No edge bonding just means that it's old and before they decided to put edge bonding on every single chip. Yes, lots of flux. What temperature are you using? I have my station on 11, so 11. It's also the volume I have my speakers on. There we go. It's starting to move a little bit. Just want to rock it off. Knock it over. And see it knock back into place. This one doesn't want to swim. It's got too much hair under it. Ugh. Oh, Jesus Christ, man. Gross. So we're going to put this through the ultrasonic cleaner and take it out and hope that we've got ourselves 12.6 volts. So let's go for that. Going to get our multimeter on here. Serial. Come on. Give me 12.6 volts. 12.5 volts, not 12.2 or 12.3. All right. 1, 2. You motherfucker. Oh, fuck this piece of shit. All right. Do I have a... No, I'm not going to look for a 2530 board to get an SMC. Am I really doing this? I'm not doing this. No, I can't be. No, I have better things to do with my time. No. No way. Stop. Stop digging. You know what? No, I'm going to go for it. We're going to go for it. I'm going to take the SMC off of this, and I'm going to put it on this, and let's see what we get. We're going to do this. We're going to actually do this. All right, so let's replace the SMC on a machine from when Lewis was too young to drink alcohol legally. Let's go for it. Let's go for it. Let's rip that SMC off, man. Let's rip that SMC off, man. Can't believe I'm putting time into this. There's so many things I could be doing. What is wrong with me? All right, that's our old chip. Now we're going to put on a chip that comes off of a board that was fixed in China 7 years ago that was deemed no fix. Okay, wicked nice and easily. Notice how much easier it is to wick the old boards than the newer ones. This was back when modest soldering equipment could actually be used to work on this stuff. All right, so we're going to put this aside for the moment. And now we're going to remove this SMC from this pile of crap. Ah, shit. Oh, boy. Oh, God, that's awful. What the Whoa. Okay, thank God this was the donor board. Never do what I just did. Never do what I just did. Never do what I just did. Wow, that was awful. All right, so let's get this thing into my clamp. Yeah, no. Almost. Almost screwed myself. One of them was popping up slightly. I gotta heat them up as quickly as I can and get out of here before the middle ones start popping off into the other outer balls. Okay. Got you. I got you there. Alright, how much did I screw up this time? Oh, you're get the not as much as I thought I would. Okay, a little bit. Some of my balls are a little big. What are you gonna do? Some of my balls are too big for their own good. That's good for the... Okay. Okay, so we got an SMC here that came off of a board that was no fix from the place that I used to outsource boards to about 6, 7 years ago. And yes, we are actually using this in the hopes that it will work. Dark days, dark days. And here we go. Wish it luck. Okay, we've preheated for a little bit. Give some time for that excess flux to go away. Now we're going to go in for the kill. Okay, it just went into place. Now we're going to make it dance. About 5 seconds of dancing. And away we go. Let it cool off. Rapid cool technology. So we're going to use rapid cool technology to get it to cool off sooner. How will it work if you don't add thermal hair under the chip? Alright, let's see. I'm going to cool it off. Okay, I'm pretty satisfied that that's cooled off now. I'm going to plug it in, and let's even see if we get a green light on this piece of crap. Do we even get a green light? I will be surprised. Doesn't seem like there's a green light, and I'm pretty sure that when I test PP Bus G3 Hot, we're going to be worse off than we were before. PP Bus G3 Hot is 12.3. Oh. 12.3. And we don't have a light on the charger anymore. Which means that the SMC that I took off was actually better than the SMC that I put on. So this board was in the pile as a donor because it has a bad sound. Yeah, so am I going to waste more time on this after I've wasted this much time already on something from 2009? Enough is enough. I give up. That's it for today, and as always, I hope that you learned something from my stupidity. And now, time for an advertisement. This is our website here, mailin.repair. You will be able to find most of the different cleaners, stencils, connectors, ICs, and small chips that we use throughout these repairs on this website. So here you'll find the ultrasonic cleaner that we use at the store that's fixed many of the boards that I was unable to fix in the video. This here is shipped straight from the store. Here you'll see a bunch of LCD connectors. We've got keyboard connectors. We've got digitizer connectors, and they're all organized here. So if you go connectors by type, or you can search by your device. So if we go here, components by device, iPhone 6S, it'll bring you to a screen where you'll find a bunch of different parts for your iPhone. The same is true for stencils. We've got stencils over here, like the SMC stencil, that it's typically hard to buy directly in America. You'll have to wait a long time to get that from China. Here we've got the some different parts, like the PP3V42 regulator over here. So this is a PP3V42 regulator. You can actually search by the number on the schematic, and if there are different chips with that same number, it'll bring up all the different chips. You can scroll down and figure out which one is for your motherboard, because over here it'll say compatible boards, and it'll list all the boards the chip is compatible with. If you don't want to deal with that, you can even just search by your motherboard. So if I search over here for 820-3462, it will only show me chips that are compatible with my model motherboard. And this was all put together with high-resolution pictures so that you can compare it to your chip to make sure that you buy the right one. And if you ever have a question, feel free to email, feel free to comment, feel free to live chat. So thank you very much for watching the video. Thank you very much for your patronage if you used our website. We've also got flux here if you want flux. We've got solder paste over here if you want solder paste. And we've even got mouse pads with pictures of my asshole of a cat.